Hey there, we are talking Faraday's law of electromagnetic induction. And what Faraday's law says is that if you change the magnetic flux through a conductor, through a piece of metal or things like wire loops, like a solenoid, you can induce voltage. Okay, now Faraday called that the electromotive force, the EMF. But nowadays we might think of that as induced voltage being created. So changing magnetic flux makes electricity, basically. Magnetic flux is magnetic field times area, okay, the area that the magnetic field is going through. And any change in that product of field times area causes voltage to turn on. It's one of the great discoveries of all time. And one of the ways you can do that is to keep the area fixed, okay, constant area, but do something to change the magnetic field going through that area. Okay. So mathematically, this would be the induced voltage is equal to area times dB dt. Okay, the rate of change that you have for the magnetic field that you're using. I just want to show some simple lab examples of how this works, okay, for this version of Faraday's law. So I have a voltmeter attached to my solenoid. I'm just going to keep it there. And the area that we want is that cross-sectional, that circular area of the tube. And I can take a magnet and I can place the magnet inside the tube. Now, if I just hold it there, we have flux, right? We've got a magnetic field going through that area. That's flux, but it's not changing. There's no voltage. If I move the magnet, though, if I change the strength of the magnetism going through that area, I can make that jump and create electricity. Now notice, if I push it in, that's an increase in flux, and the voltage was actually negative. Okay, watch the sign. When I pull it out and I decrease the flux, it goes positive. And if you just do that, change it from negative to positive, that's an alternating current that you're inducing in this coil of wire. It's that easy to make electricity. You move a magnet. That's all you have to do. Okay, that's kind of cool. Now, this thing over here is another solenoid, which I have plugged into an outlet. So there's actually an AC current running through the solenoid, through this wire. So the electrons are flip-flopping back and forth in there. That changes magnetic field to flip-flop. Okay, that's a change in magnetic field, an AC magnetic field. I could take my tube and hold it up here, and notice I'm getting voltage again, because that AC magnetic field is going through that area, through the tube, causing a change in flux, and Faraday's law says that has to induce a voltage. Okay. It's making electricity right now. Now that has some other implications. I could take this little loop of aluminum, which is not magnetic. It doesn't stick to a magnet. I could hold it on here. There's a change in flux through this. It actually gets warm. Of course, you can't feel that, but if you're ever in the lab and can do this, it gets warm really quick, within seconds. It has resistance, and that's indicative of the current that gets induced in this little loop of metal, okay, due to the changing magnetic flux caused by this change in magnetic field right here going through this area. What's more, nature doesn't like this. It jumps up, it leaves, it escapes. It doesn't like that change in flux. That's called Lenz's law. I can take other magnets here. These little loops of metal are actually magnets. Watch what happens if I hold this. They spin like crazy. If I pull it away, it stops. It's really weird. Some of you might have seen these types of flashlights before. It's like a pump flashlight. If I shake it, a little magnet runs through this little solenoid. Okay, again, loops of wire. That would be a changing magnetic field going through that area. That's a change in flux, and that creates an induced voltage and current. So if I shake this, I can actually get it to light up. When I stop, it turns off. Faraday's law. To see a bigger effect, we have things called transformers. Okay, transformers are cool because it's two separate coils, and all they share is just a piece of metal that goes from one tube into the other tube, but they're disconnected from each other. And what happens is if you put an AC current in one coil, okay, the input side, it makes an alternating current inside the wires. That causes a changing magnetic field, which causes a change in flux in this little metal piece that's coming out of that tube. That current that comes through here starts to alternate inside the other coil and induces a voltage and current in that coil on your output side. If you have different numbers of loops of wire on the two sides of a transformer, you can change the AC voltage on one side to get a different AC voltage on the other side through induction, okay, through Faraday's law. This is how transformers work, and we'll talk about that in class 2. Okay, so the wonders of the world, including light. Okay, the first thing in Genesis is God created light. It's an electromagnetic wave caused by this induction process. Changing one field, say an electric field, induces a change and turns on the other field, the magnetic field, and vice versa. That's how electromagnetic waves can move through empty space. It's amazing. Faraday's law is really cool, and we're going to be talking about these examples quite a bit in class. So until next time, we'll see you later.